In this problem, I'm testing the equation r equals 5 times sine theta times cosine squared theta for symmetry with respect to the pole, the polar axis, and the line theta equals pi over 2. Recall that when we are testing for symmetry with respect to the pole, we're replacing r with negative r, and we're going to check to see if the two equations are equivalent to each other. So now I've rewritten the equation in the form, replacing r with negative r. So I have negative r equals 5 sine theta cosine squared theta. And I can solve this for r by multiplying both sides by a negative. And I want to do that because I want to have r by itself. In the original equation, r was by itself. So I have negative 5 sine theta cosine squared theta. Okay. There's no way to turn this into a positive 5 sine theta cosine squared theta. So there's no way for that negative sign to just disappear. And so therefore we'd have to say that the test is inconclusive. I don't know for certain that this is not symmetric with respect to the pole. So inconclusive. Let's check the next thing. Now when I'm checking for symmetry with respect to the polar axis, then I'm checking to see, does the point r comma negative theta give the same equation as r comma theta? So now I'll replace the theta with a negative theta and see what I get. Now I have r equals 5 times the sine of negative theta times cosine squared negative theta. And this is something that I can work with. I can take the negative out of the sine of negative theta, and I know, because I know sine of negative theta is equal to the negative sine of theta. Remember that sine is an odd function. We learned that a few chapters ago. But how about cosine squared of negative theta? Well, I know cosine is an even function, which means that the cosine of negative theta is simply equal to the cosine of theta. So cosine squared of negative theta is just going to be cosine squared theta. And therefore, I get something that is, again, not equal to what we started with originally. So, again, my test is inconclusive. Now, finally, I will check for symmetry about the line theta equals pi over 2, and this is where I take r theta and replace it with r comma pi minus theta. So again, I'll rewrite my equation, taking out the theta, replacing it with pi minus theta. So I have r equals 5 times the sine of pi minus theta times the cosine squared of pi minus theta. And now I will use my difference of two angles formulas for sine and cosine in order to rewrite this, and then I can do some simplifying. Now this gives me 5 times sine pi cosine theta minus sine theta cosine pi, and then that is multiplied by the quantity cosine pi times cosine theta plus sine pi times sine theta, and then that's all squared. And now what I need to do is evaluate the sine of pi and the cosine of pi in each of these expressions, or in this expression, and then simplify my results. So remember, the sine of pi is 0. Cosine of pi is a negative 1. So when I go to simplify, what I'll get is 5 times the expression 0 minus -1 times sine theta, close your parentheses, and then that's multiplied by the expression -1 times cosine theta plus 0 and squaring that. And so what do I get when I simplify now? Let's see, we've got 5. We've got a positive sine theta, a negative cosine theta, but then it's squared, so now it's positive cosine squared theta. So what I end up with is the original equation. And that means that we have symmetry with respect to the line theta equals pi over 2. And that concludes my problem.